Coulomb's law. Coulomb's law states that the magnitude of the electrostatic force between 2 point charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. For the main formula for Coulomb's law, we have F equal to K multiplied by Q1 Q2 over R square. F is magnitude of electrostatic charge. For Q1 and Q2 is magnitude of charges, and R is distance between 2 point charges, while K is an electrostatic constant.
Assalamualaikum warahmatullahi wabarakatuh. Here is an example question for Coulomb's law problem. There are two isolated small objects have charges of 0.04 mu coulomb and negative 0.06 mu coulomb and are 5 cm apart as figure below. What will be the magnitude of electrostatic force acting on each object? First and foremost, we need to draw and understand the direction of electric force acting on each object, where Q1 move to the right while Q2 move to the left because Q2 have a negative value charge. Next, find the magnitude of force on Q1 by using the main formula of Coulomb's law, which is F equals to K Q1 times Q2 over R squared. K is 9 times 10 power of 9, Q1 is 0.04 mu coulomb, Q2 is 0.06 mu coulomb where there is no negative because we only want the magnitude, while R is 0.05 meter. The magnitude of force on Q1 is 0.0864 Newton. Now, we already have the magnitude of force for Q1. The third step is to write the magnitude of force of Q1 in vector component, which make it 0.00864 I. Lastly, calculate the magnitude of force on Q2, which is 0.00864 Newton, as they act on two same objects. So, the magnitude of force for each object will be the same.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rabiatul Ismail. I will continue this slide to understand more about Coulomb's law. Let us do an example which is to calculate the resultant force on the charge Q3 due to the other charges and the direction of the resultant force. So, when we get this question, the first step is to draw the direction of the electric force on Q3 due to Q1 and Q2. So, the first one is Q3 to the Q1. Since the charge is positive and negative charge, so they will attract each other and the direction of the electric force will move to the left toward Q1. For Q2, due to the charge will be positive and positive, so the same charge will repel each other, so the direction of electric force will move to the right, which is away from Q2. After we find the direction of electric force, the next step is to find the magnitude of force on Q3 due to Q1 and Q2 by using the Coulomb's law, which is F equal to K times Q3 times Q1 divided by R square, which K is 9 times 10 power of 9 and R is the direction between charge. Find for both charges using the same formula and we will get F31 is 109.95 Newton and for F32 is 12870 Newton.
So for the next step, we need to write the vector component. We can find the vector component of F31 and F32 by using the IJK form. So the vector component of F31 is negative 103.95 I, and for the F32 it is 128.27 I. And for the final step, we need to total up all the forces. Find the resultant forces F net equal F31 plus F32. We need to identify the direction and magnitude of resultant forces from the F net. So from this, we got 24.32 I. Hence, the magnitude of total force is equal to 24.75 N. And the direction is in positive x-axis direction.